Hi everyone, my name is Alon Jacovi. So let's begin. Basically, this paper is about trying to understand what would it take to explain AI behavior. Okay, I'll just start with a few disclaimers about what this paper isn't, because these are popular topics lately. Basically, it's not about saying whether AI models should or should not have theory of mind, or whether they do or don't have theory of mind. What it is about using theory of mind as a mode of communication for communicating information about behavior, just a qualitative study about what we can take from theory of mind literature for improving explanations. Okay. It's basically, let's say we have a user who is looking at an explanation of AI behavior. We want to say, when would they say that they understand what the AI did, or when would they say that they don't understand? We just want success conditions for explanations. A basic way to do this would be, first of all, to say what are the desiderata of good explanations. So, for example, faithfulness or sufficiency or minimality, plausibility, and so on are properties like this. But if we look at what the explainers actually understand from the explanations, maybe we can formalize this a little bit differently. And we will refer to the explainer's understanding of the behavior as the explainer's mental model. Okay. Basically, let's look at this as a function. The standard or traditional way to do this would be to look at the explainer as a function based on the event that will produce an explanation. Okay. Then we can evaluate the explainer like climb and shop and so on based on properties of the explanation. Okay, and that's how it is usually done. Okay. But what we can try instead is maybe let's look at the explanation itself as a process based on the event that we are explaining and the user who is participating in the explanation. And the output of the entire process is the explainee's mental model. Okay. Based on this, we can evaluate the explanation based on properties of the mental model. And we can define when an explanation is successful based on how the mental model manifests. Okay. So what this means, just jumping to the end of this line of thinking, is that we will define an explanation as successful if it produces a mental model which is coherent across multiple instances of AI behavior. Okay, I will just run through this in an example to illustrate. So let's say we have this case of carnivorism prediction. And let's say the explanation is that the model was recognizing cat whiskers in the image. So let's assume that the mental model of the explainee here is that the model looked at the cat whiskers of the image of the cat, recognized the whiskers, and therefore said that this is a carnivore. Okay. In another instance, though, let's say we have this image of a rhino, and the decision and the explanation were the same with the whiskers, but this is obviously incorrect. The issue here is that our mental model from before does not apply to this case because there are no cat whiskers in the image that the model can recognize as cat whiskers. What we can do is we can update our mental model to account for maybe the model misrecognized the long grass in the image as cat whiskers. Okay. In this case, the mental model actually is consistent with the previous image because the previous image also had long graphs. So maybe this mental model is more coherent across both instances compared to the previous mental model. Okay. This is the idea behind the success conditions based on coherence. It basically means that instead of trying to formalize the correctness of an explanation, we allot an empirical budget to searching for contradictions over multiple cases, and then interactively after this process we will find at the end the coherent mental model. Based on this, we can construct an explanatory narrative based on the success condition of mental model coherence. Okay, so this is how it looks in the paper, but we don't have time to go into all of the small details. I will just run through this with an example to illustrate. The idea is that we can take the components of four concepts of behavior from theory of mind literature to see what is intuitive about communicating behavior and taking this into account for our explanations. Okay, so in this example, let's say we have a self-driving car with an AI component. And let's say the car drove into a wall and we want to understand why this happened. Okay, so the explanation I can give you is that the car in this case drove at 50 kilometers per hour when the speed limit was 20 because it mistook a nearby 20 sign for a 50 sign when the camera of the car was dirty, and that's why. So the car hit an unobservable bump in the road at this high speed. It lost steering ability, and that's why it veered off road into the wall. Okay, so this is the explanation, and now let's try to map this into our explanatory narrative from before. So the explanatory narrative has these components. Basically, the representation causes are everything in the world that affected the AI's internal representation. So, for example, the sign, or the dirt on the camera, or the camera itself, and so on, are the representation causes. The internal representation is everything in the world that it's basically how the AI perceived the world. So, for example, the fact that the sign reads 50, or the fact that it should drive under the speed limit, and so on, are internal representations. And the external causes are stuff like the hidden bump in the road that had an effect on the event but did not have an effect on the AI's perception of the world. Okay? The contrast cases are the interactive cases that we would search for to find contradictions to our explanation. So, for example, the contrast case of having a clean camera or having a road without a bump and so on, if the event did not happen in these contrast cases, then we can say that the mental model was coherent across all of these cases, and that's why the explanation was successful. Okay, that's the idea behind the narrative. The entire point of this exercise of mapping it into concepts is that if parts of the narrative were missing, like for example one of component, then the explanation would be harder to understand. Okay, so if we go into the explanation methods that we are familiar with, like training data attribution, where we say the explanation happened because of these training instances, then we can try to understand what happened. So in this case, in training data attribution, it gives us the representation causes. It says what caused the AI's representation of the decision, but it did not say what the model is representing about the images or the differences between the images or the similarities. Okay, and that's why this can be problematic when understanding the explanation. In the same way with feature attribution, by attributing parts of the input into the output, it gives us the representation causes. It gives us what had an effect on the AI's representation, but it did not say what the model is representing about this attributed part, right? In the concept attribution explanations, like the one we saw earlier with the cat whiskers, it's a bit different. It gives us the internal representation of the model. It says what the model is representing in the input, but it's not giving the representation causes. It's not telling us what in the input had this effect on the AI's representation, or why the AI is representing cat whiskers in the input, right? And this is essentially what happened in the contradiction with the rhino case. Right? So this completes our mapping of the explanatory narrative. The idea finally in the paper is that first of all we have the success conditions for an explanation, and we use this definition to construct an explanatory narrative. The idea is that this will be an intuitive way to communicate explanations. Thank you.